Okay, now again, we can have some transformations of these guys. Transformations that we can do is we could put a negative out front. We could add or subtract a number inside the logarithm with x, and we might add or subtract a number outside of the function. And we have programming to know what these guys do. So if you have a negative out front, then you will, I'll say, flip the graph upside down. Over the x-axis. You'll flip it vertically over the x-axis. If you add or subtract an h inside with x, this is going to shift you left and right, and it's going to go the opposite way that you think it will. So if you subtract h inside, then that shifts the graph to the right h units. And if you add h, that will shift your graph to the left h units. It's going to go the opposite way you think it will. And if you add or subtract a k to the outside, that's going to shift you vertically up and down. And this is going to move the way that you think it will. If you add k to the outside, it will shift your graph up by k units. And if you subtract k from the outside, that shifts your graph down by k units. So this one has a vertical asymptote, right? These log functions have vertical asymptotes here at x equals 0. Which transformations here will affect your vertical asymptote? Well, if you take this whole thing and flip it upside down, your vertical asymptote stays in the same place, so that won't change. If you shift this graph up and down, your vertical asymptote, if it moves up and down, it stays in the same place. What if you shift your graph left and right? Then your vertical asymptote would move with your graph. So I'm just going to make a note here that your vertical asymptote shifts left and right with your graph. So for instance, if you move your graph to the left by 3 units, then your vertical asymptote would move from x equals 0 to x equals -3. You would move it left 3 units. And again, we are going to note that order matters. When you are transforming graphs, the first thing that you're going to do is shift your graph to the left and right. Second thing that you're going to do is flip it upside down if you need to. And the very last thing that you're going to do is shift that thing vertically up and down. All right, so let's practice this thing. Okay, so again, we're going to list the transformations in the order that they would be performed. So if I wanted to graph f of x equals log base 2 of x minus 2, we aren't asked to do this, but the graph that we would be transforming is the base graph. So if we remove any transformations that appear here in our function, what we would be left with is log base 2 of x. This is our base function, and we know what that looks like. We just graphed it up here. Log base 2 of x is here. It increases from left to right, and our base function looks like this. And so, excuse me, that would be our base function. What transformations have to happen to make it look like this? Well, the transformation that appears here comes from this -2, and that is being subtracted inside with x. It's going to shift us right and left. It's going to go the opposite way you think it will. So this is actually going to shift our graph to the right by 2 units. And that's the only transformation here, so that's the only one I'm going to do. All right, number 2. G of x equals log base 2 of x minus 2. Okay, again, our base function, if we got rid of anything that makes a transformation, we would be left with y equals log base 2 of x, which is this increasing logarithmic function here. And the transformations that we have here come from this minus 2 outside, and that is going to shift us down 2 units. That's the only transformation, so that's the only thing we have to do. All right, how about if I have h of x equals 1 minus log base 2 of x? This looks a little different than this because we always start with the log first, and any other numbers being added or subtracted are written on the right. So I'm just going to reorganize this. The negative stays with the log since it's negative. So I'm just going to rewrite this into negative log base 2 of x plus 1. The log is negative, the 1 is positive. So I can rewrite it like this. Again, if you get rid of anything that makes a transformation, our base function is y equals log base 2 of x. And the things that cause transformations are this negative out front and this plus 1 here. This negative out front will flip us upside down. And this plus 1 out here on the end will shift us up 1 unit. Order matters, so what am I going to do first? I'm going to flip upside down because you have to move up and down last. Okay, so we're going to flip upside down over the x-axis first, and then the second thing that we're going to do is shift the graph up 1 unit. All right, last one. K of x equals log base 2 of x plus 5 plus 3. Okay, again, our base is y equals log base 2 of x. The things that cause transformations here are the plus 5 and the plus 3. The plus 5 is inside with x, so that's going to shift us right and left. And that's going to go the opposite way you think it will, so that's going to shift us to the left 5 units. And then this plus 3 is outside, so that's going to shift us up and down. And that's going to go the way you think it will, so that's going to shift us up 3 units. Order matters, so we're going to go left 5 first, and then we're going to go up 3 next. All right. Now we actually want to use the information that we have above to graph log base 2 of x plus 5 plus 3. So we just actually went through this one right here. So I know that I'm going to take the base graph of y equals log base 2 of x. And I'm going to take that graph and I'm going to shift it to the left by 5 units and up 3 units. So let's start by graphing our base function of y equals log base 2 of x. We just did this a few minutes ago. Y equals log base 2 of x is here. And we'll have the point, I'll just do 2 points here. 1, 0, and 2, 1 were on this graph. So I'll just start with those. So 1, 0, and 2, 1 were nice points on this graph. And so here is my log base 2 of x. That's my base function. Okay, so now I'm going to take this function, and I'm also going to make sure that I put in my vertical asymptote here. And then I have to shift this thing to the left by 5 units first, and then we will go up. So the first thing that I'm going to do here is go to the left by 5 units. So I'm going to take each of these points and go left 5. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So notice this looks like this. Now, when I shift this to the left, notice that my vertical asymptote is going to shift with the graph. So my vertical asymptote moves with the graph over here. My vertical asymptote is now at x equals -5. And then the last thing that I have to do is shift this thing up 3 units. So I'm going to take each of my points and go up 3 units. 1, 2, 3. 1, 2, 3. And here I have my final graph. And so since that's the last thing that I had to do, I'll put my points in. I've got 4, 3, 3, 4. It looks like this. And my vertical asymptote here is x equals -5. That's my final graph for y equals log base 2 of x plus 5 plus 3. All right, so I hope that helps with the graphing logarithmic functions and finding their domain and range. And I will see you next time.